Hello, today we're going to talk about conditional statements. So, here is a table of contents with the topics in order of what we're going to be discussing. If you're interested in going back and reviewing topics, you can go back and here's the order of all the topics we will be talking about. So let's start by an introduction to conditional statements, more specifically the if statement. We use conditional statements for every decision we take in our everyday lives. Now let me give you an example. We use the conditional statement like, is the weather cold today? If the weather is 30 degrees, then it is not cold and we will wear something warm. But if the weather is negative 10 degrees, we're talking Celsius here, then we will wear something warm. Now this seems like a very simple concept, but it can get a little bit more complicated in programming, more specifically in Java. So let's talk about it. Java supports specific statements that allow us to check a condition and execute a specific section of the code depending on whether the condition is true or false. Now this seems like a lot of words, but let's get the meaning. So let's explore this for a diagram right here. We're running our program and we run into a condition. If this condition is true, then we run a conditional code that we have sectioned off specifically for the case that this condition is true. Now if the condition is false, the conditional code does not run, and we continue on to the next part of our program. So to create these conditions, we use Boolean comparison operators. Boolean comparison operators can be used to compare integers, which are simply numbers with no decimals, floats, which are numbers with decimals, chars, and finally Boolean, so Boolean true or false. So we use these simple, these are the most basic and most commonly used operators. There are way more, but these are the ones that we need to learn for this unit. We have the equal to operator. We have the equal to operator. So let's say 1 is equal to 1. This would be true. We have the not equal to, greater than, less than, greater than, or equal to. These are a little bit more complicated, as this condition basically checks if we could place 1 is greater than or equal to 1, and this would turn out to be true, or you could place a 2 is greater than or equal to 1, and this would also turn out to be true. We will explore this in later slides. So here are the examples. We have highlighted sections of this table. The green highlighted sections will run, the red will not run. So let's take an example for the equal to operator. We have 1 is equal to 1, well 1 is 1, so the code will run. This means that this condition is true, therefore the code will run. But if 0 is equal to 1, the condition is false, the code does not run. Same thing with the not equal to, so if 2 is not equal to 1, well 2 is not 1, so the condition is true, therefore the code runs. If 1 is not equal to 1, well 1 is actually 1, so it is not equal to 1, the code will not run. The condition is false, the code never runs. It gets a little bit more complicated, as I mentioned earlier, with the greater than or equal to operator. So if we have 1 is greater than or equal to 1, this condition is true, therefore the code will run. But if 1 is equal to or greater than 2, well 1 is neither greater than 2, nor is it equal to 2, so the condition is false, the code does not run. Same thing for the less than or equal to operator. You can explore this chart a little bit more to understand Boolean comparison operators. Now what we just explored are simple conditional statements. Now we can make more complex conditional statements by using Boolean logical operators. Now these allow us to combine two conditions into one statement. These are used to apply more specific applications of real life into our programming experience. So the two that we're going to be exploring today are are and or, symbolized by these two symbols right here. This is and this is or. So let's say that we have a conditional statement whose condition is 1 is equal to 1, Well, that condition is true, and what we have done here in this table is simplified that by simply stating if a condition is true or false. So we have two variables, a and b. Variable a is false in this example, variable b is false in this example. A or b, well, both are false, so we get false. A and b, well, both are false, so we get false. In this example, we have a being a true condition, b being a false condition. If we compare them using the OR logical operator, well, it will favor the true, so it will favor A, and we get a true conditional statement. Now, if we compare true and false, and we use the AND logical operator, we get false, because true and false is false. Vice versa, false and true, we have the same outcomes as true and false. If we have true and true, well, true or true is true, and true is a true outcome. Now we can get a little bit more complex with the if statements. Basically, when using an if statement, the user has the option to section off code to be executed in the case that the condition within the if statement is false. This piece of section off code is placed within an else statement after the if statement. Now, what this means is that if we have conditional statement whose code does not run, we can section off another piece of code to run in the case that the if conditional statement is false. Now take careful notice that in these examples the if statement has a condition, the else statement has no condition. The only condition that the else condition has to run is if the previous if statement is false. So in these examples here we see that if the condition within the first if statement is true, the code runs. And the else code does not run. But if the first condition is false, the code does not run. So the else statement runs, and it runs the code inside of it. And to explore this in a flowchart diagram, we see that we have a condition. If this condition is true, let's say we're using the condition again, is the weather cold today? If the weather is -10 degrees, well, this is true, the condition is true, therefore we run the code within that section. But if the weather is cold today and we have a weather of 30 degrees Celsius, this condition is false, therefore we never run the if code and the else code runs. These are just two simple ways of visualizing this process. You can explore this more by analyzing these two resources. Finally, applying the knowledge that we have learned from if, simple if, and more complex else statements, else if actually, we can apply this to basically an if else if ladder. And basically it's a series of conditional statements that will execute only one piece of code. Now these ladders, these series of conditional statements are applicable to a lot of very interesting situations in real life. Now let's say that we're designing a program to, let's say, find a driver who's driving over the speed limit. Now if you're familiar with find values vary depending on the amount that a person is speeding over the speed limit. Now for this example, let's say that 10 kilometers per hour over the speed limit is $10, 20 kilometers over the speed limit is $20, and so on up to 40 kilometers per hour, where the fine will be $40 for 40 kilometers per hour or over. This is how we would structure this and apply it to the if-else-if ladder. Our first condition would be if the speed of the car is 10 kilometers per hour or less over the speed limit, we run a statement which fines the person for $10. Let's say that we're speeding, let's say 18 kilometers per hour over the speed limit. Well, this condition is false because it is not 10 or less, but this condition here will check if it's 20 or less. So this condition is true, the statement runs and we continue on our program. If we're speeding 21 kilometers per hour over the speed limit, this condition is false, this condition is false. So the third condition is if the speed of the car is 30 kilometers per hour or less over the speed limit, the third condition will run and we continue on. But if the driver is speeding over 30 kilometers per hour, we have the final condition, which is basically 30 and over, and they find whatever the amount is, and we continue on in our program. Now this is a very interesting series of conditional statements that have infinite applications in real life. I just gave you one, but you can find amazing, infinite amount of applications for this. So let's look at some examples in a chart to further understand this concept. In the first example, we have the first if statement giving us a true conditional statement. Therefore, the code within this if statement will run, and it will neglect the code within the else if statement and the else statement. Now, take into consideration that we did mention that previously the else statements have no condition. Their only condition is to run if the previous if or if else statements do not run. But the else if statement does have a condition in the same way that the if has a condition. So in the next example here, the first condition is false, the code does not run. The second, the else if statement checks and his condition is true, therefore its code run, and else does not run because this code right here ran. Finally, the first if condition is false, the code does not run. The second condition for the else if is false. Therefore, since these codes did not run, the else condition runs automatically with no condition at all. Now we have been exploring comparing booleans, which are true and false, chars, integers, which are numbers, and floats, which are numbers with decimals. But we cannot compare strings and objects with the equals or greater than, etc. Operators. The reason for this is that the equals operator compares a reference. So it compares, let's say, the number 1 to the number 1. If they have the same location in the memory, then it determines that they are equal. But it is not checking the actual value of the integer, of the variable. Now this is perfectly fine for booleans, chars, integers, and floats, but not for strings or objects. You see, we cannot compare the string A to the string B using the equals operator. We will always, this will not work. So for this, we use the dot equals method, which is used to compare the actual content of a variable. So if we're comparing the string A to the string B, we simply say A dot equals, and inside the brackets we place the letter B, and we can in this way compare the actual content of the variable. Same thing with objects, but I will not explain this because we will be later getting on into objects. Here are some resources that I think you can find helpful. The Oracle website has all the methods and all the comparison operators, all the logical operators that you will need. It states the use of these operators and the actual application and how to use them. Next, we have Quizlet. Quizlet, I have designed a set of cards to teach and test your basic knowledge that you have learned in this presentation. Finally, the Kahootis, to test the application of your knowledge that you have learned. So I recommend going in the order that this is set in. Thank you very much, and I look forward to the next lesson.